like what you will do Wednesday, Thursday, and Friday. And tomorrow's stuff is kind of what you'll do Thursday and Friday. So we're going to start with a few little things. It says that, let's see, we have this right here. They'll use letters. Okay, this is called the radicand. The letter A is. Okay, this is the radical sign. Okay, it's a radical, also a square root or whatever. And then the N is the index. You may have a problem like this on your worksheet. I can't remember. And I may already do this in the next video too, for Wednesday. So anyway, it's square roots. Okay, y'all, what's the square root of 36? Okay, so we're at a good start.
What chapter?
Okay, this is chapter 6. Anyway, we use the word square roots, but this is the index. This is called a radicand. Other than on that worksheet, we don't say this, okay? This is the radical sign. I will say that sometimes, okay? So we're going to find roots. And so one of the ways you can do it is using your calculator. That's fine, unless it gives you a decimal. I don't want decimal answers. On your worksheet, there's a possibility that, did I press record? I think I did. Yeah. There's a chance on your worksheet that it says give your answer in simplest radical form and decimal. I don't really care about the decimal answer. I just want us to simplify radicals today.
So where do you get to it to do it on your calculator?
Okay, so if we were just trying to find basic square roots, you're going to press second and, oh, you can't see, hold on. Second, and then do you see this x squared button? X squared and then the square root sign, mine is in blue. They're on the same button because they're like inverse operations. If you square a square root, it cancels out. Anyway, so you just press second, that button, and notice it gives me the square root. And then I would just type in 36, enter. There it is. It's great. Now, here's the problem. What if I said the square root of 48? That is not my answer in simplest radical form, okay? So I don't want that answer. I'm going to show you how to simplify. I think we've done this. Have we done this some? I'm hoping so. We're going to add variables to it. That's what's going to start to get different. Okay, so what if I want us to find the square root of 16 over 81, all right, without a calculator. Can somebody tell me what's the square root of 16? 4. Okay, what's the square root of 81? There you go, 4 over 9 is your answer. Okay, what if they had a negative sign out here? What would my answer be? Negative. What if they had a weird sign, like plus or minus? Then you'd put plus or minus. That means I could have the positive or the negative. Okay.
There's no imaginary numbers.
No imaginary. So we're about to, look, I'm about to put this down. The square root of negative 16. Type that in your calculator and it gives you an error. Can you find the square root of a negative number? No. It's imaginary and we're not doing that right now.
Take an eye out.
So, well, we're not. I actually accidentally said that in your video on Wednesday. I was like, oh, Algebra 2 students, you take the I out. And then I realized, oh, just kidding, we're not doing I's in this chapter. So this one, you can't find the square root of a negative number. It doesn't exist.
So no answer?
So there's no answer on that one, okay? So is everybody understanding square roots a little bit right now? Okay, and I'm going to go from square roots. I do want to write this on the board. I know it's not going to be in your video, and I write this in several of the videos, and I may leave it over here on the board for you. I've written this down for you before. Let's put some perfect squares and perfect cubes up here. So like, what is 1 squared? 1. What is 2 squared?
4.
3 squared?
9.
4 squared?
16.
5.
25.
Okay. 6.
36.
7. Okay. 8 squared?
64.
9 squared? 10 squared? 11 squared? and 12 squared.
1.4.
Okay, 8 squared. 9, 10, 11, 12. Okay, this will help you as you have to find, because we're going to start simplifying it a little bit, and I'm going to say, what number goes into this? Well, you're going to look up here. I swear we've done this before. One of these numbers
We
might
definitely
go,
have.
yeah.
this on that side.
Okay, now, then we might have cubes, okay? So if I'm not gonna have to go as far because they grow like super fast, like exponentially. Like, what is 1 to the third?
1.
What is 2 to the third? 3 to the third? 4 to the third?
Don't know that one.
5 to the third?
1.5?
6 to the third?
Don't know that
I
one.
forget it every time. 7 to the third?
Nope.
It's 2,
Oh, just kidding.
96. What is 6 to the third? Right here.
216.
216. I knew I didn't know that one. Okay, that's high enough. I'm not going to have numbers bigger than this to divide by. I didn't even need that one probably. Does everybody understand that? So then, if there was a fourth root, I could do the same thing with the fourth power, and then the fifth power or whatever. You don't have to write very many of those at all, because 2 to the fifth power, I'm already up there at 32, I think. Okay? So it grows fast. Now, this one, let's see. What if I have, okay, we could not do the square root of negative 16. So I think for their answer, they would just put, let me see, no real roots. I think they just put no roots. Okay, everybody good with that? Now, let's move on. Let's do the cube root of negative 8. Okay? Cube root of negative 8. You can actually type that in your calculator. What is the cube root of negative 8?
Wait, how can you do that?
Oh, okay. So, and we don't always want to use our calculator, but I press math, and number 4 is a cube root. And you shouldn't get an error. It's the cube root of negative 8 is negative 2. You can, if it's an odd root can have a negative underneath. Okay? I think I've talked about that before. An even root, like a square root, a fourth root, a sixth root, see how all those are even numbers? No negative numbers are allowed. Because a negative times a negative is always positive. When you're multiplying two things or an even amount of things, it's always positive. On this one, what's a negative times a negative times a negative?
Negative.
I know, that's a negative. That's why you can have, it's weird, I know, but that's why you can have negative under a cube root. You can have a negative under a fifth root, a seventh root, a ninth root. Any odd root can be negative. So, yes, you can type in your calculator, or just look up here. Look, what's the cube root of 8? What am I cubing? 2. That's what you're looking for. And since it's a negative 8, my answer is negative 2. And yes, on this one you can use your calculator, but in a little bit, we can't use our calculator. So we're going to try to get used to that little chart over there. Helps so much.
I'm gonna write it on the
Okay, like this one, the fourth root of negative 1. What do y'all know about that? Can you do that one? Can you take an, no real root.
So
So
there's
it's-
an actual answer of no real root?
Yeah, that was the answer to the negative 16 up here as well, as no real root.
No solution.
Or no, yeah, I said no solution, like, because there's no answer for it. There's imaginary, but like I said, we're not doing imaginary. Okay, let's see, what about, this one's kind of confusing. The square root of negative 7 squared. Well, first, what is negative 7 squared? I want to see what they put.
Wait.
What number is that?
Yes.
2. Yeah, this is 7. Yeah, it's going to be the square root of 49, which is what? 7. Okay, just kind of work that one out. Because negative 7 squared is actually a positive 49. And I can take the square root of positive 49. That one, they put it in parentheses, that like I would in my calculator, because they want you to know, hey, I'm squaring that negative sign, so it's going away. That's what happens when you square a negative. Okay.
If you don't put the parentheses around it.
then it might mess it up. Yeah, that's why, because it's leaving the negative in there. Okay, it's not squaring the negative. So if they put the parentheses, you put them. All right, now we're going to take this a step further. There are some absolute value bars that we're going to use. I don't think on your worksheet that I give you for the next few days, there's no answers with these I don't think the worksheet puts these in the answers. I'm not really sure. But I want to teach you like the book does. After this lesson today, though, I think we kind of leave the absolute value bar thing behind. But there's a rule, and I do want us to learn it. First step, okay, it says when you take, I'm trying to think the best way to word this. When you take an even root, sometimes you have to put absolute value bars around your answer. When you take an odd root, you never do, okay? But if you take an even root, where's the problem at? And you get an odd exponent, that's when you put absolute value bars. That's your little, I guess, our guide, the easiest way to explain it. So here, let me do this problem. It's kind of a lot just for a few minutes. 16x to the 8. This is a square root. Does everybody understand? It's a 2 right here, but we don't ever put the 2. Do y'all know that? That's what a square root looks like. It's got the 2. Everybody knows that because square is a 2. We just don't ever write the 2. It's like an understood thing. Okay, so the square root of 16 is easy. What is the square root of 16?
4.
It is 4. Okay, now we have variables. All right, what you do is you just divide that exponent by the root. This is a square root. What number did I tell you that is? A 2. What's 8 divided by 2? 4. That's my answer. You just divide it. That's all you do, you divide it.
Oh, no.
So I took the square root of 16. It's 4.
So if it were cubed, you would divide, it'd be 8 divided by 3?
We'll get to that later. But yes.
Okay.
And we can't do that, but we can split up our variables into x to the 6 and x squared. Anyway, we'll get to that. We'll get to that. We're going baby steps, okay? So the next one, let's see. And I'm not going to put any absolute value bars because I don't have any odd exponents out here. Okay, and I'll get to that in a second too. The cube root of a to the 6th, b to the 9th. I never put absolute value bars on a cube root because things can be negative on an odd root. What is 6 divided by 3?
2.
So a squared, that's the cube root of a to the 6th. And then what's 9 divided by 3?
B to the 3rd.
There you go. That's it. You're just dividing them by 3.
That's not bad.
And it's not bad when the numbers aren't divisible. It's actually not bad at all. Okay? We'll get to that. I don't even know if we'll get to that today. Okay, now let's go back to another even root. How are we feeling on this? We're okay? All right. This should be new. The variable stuff should be new. The 4th root of x to the 8th, y to the 12th. Okay, so they're both divisible by 4, thank goodness. What's 8 divided by 4?
2.
X squared. And what's 12 divided by 4? 3. In your book, this one would be an absolute value bars in the answer. Because an even root and you get an odd exponent. It's just saying because that can't be negative under there. It can't be because it would end up, you can't have a negative under there. It's weird. I don't know.
So how would B
This one,
the one above it not be absolute?
because it was a cube root. It was an odd
so
root. Only it's an even root and you get an odd number out there. It's weird. I honestly don't know why they do it, but they do. And I'm telling you, after today's lesson, like, I honestly don't know that I take off points. The only problem is, I think on the test, there's a multiple choice problem, and you have to know where the absolute value bars go. It's like one problem on the whole test. So, let's do some more of these, and then I need to get back to some numbers. How are we feeling on this? Is it bad?
So bad.
Okay. And y'all got like, this is a whole week of this. I'm sorry. It's going to be boring. I could have made it really difficult though, so at least be thankful for that. Okay. What if we have let me find a good one. I'm done with this whole lesson, I think.
And we still have like 25 minutes.
I know. Well, I'm gonna just go through some practice problems. Oh, I could grade your test after. But let me finish my lesson.
You just said you were finished.
No, I said I'm still gonna go over some more problems. Okay.
This is probably actually one of the easiest lessons we've had all year, I feel like.
The square root of 81 x to the 4th. What's the square root of 81?
9.
And what's the square root of x to the 4th?
2.
X squared. And it's an even root. So I don't have to put absolute value bars. Okay, let me practice a few of the numbers because your worksheet Wednesday, Thursday, and Friday can have numbers like this. The square root of 48. Now, I know, what's the square root of 49? 7. I don't know the square root of 48. So this goes back to, let me look under my perfect squares and try and find the biggest one that goes into 48.
36.
So this, let's see, 48 divided by 36 doesn't work out. 48 divided by 25 doesn't work out. 48 divided by 16 is 3. So that one works out, right? I would just go down my calculator. Look, literally just do, does 48 divide by 36? No, it does not. Does 48 divide by 25? No, it does not. Does 48 divide by 16?
Yes.
Yes, it does.
Yeah.
Huh? We've done this before, yes. But it's this whole chapter, we need to be like really prepared for this in this chapter. So this is 16 times 3. Does everybody agree that's the same thing?
Mm-hmm.
What is the square root of 16?
4.
And then what do you do with that? You leave the square root of 3. So y'all already know all of this. Yes. What if I have a cube root one? Let me find a cube root. Let me do. Okay, 108. Let's do the cube root of 108. Is 108 a perfect cube? No. So we're just going to start at 64. What is 108 divided by 64? Well, look at that. That doesn't work. So what is 108 divided by, what's my next one up there?
About 9.
Well, we got to start 27. So, because you have to look at your cubes. So it's 4. 27 times 4. So let me put that. The cube root of 27 times 4. What's the cube root of 27? 3. And then put your little cube root of 4s left over. Okay. We remember all this? Yes. Y'all are going to do so much better, I think, than I expected on your worksheets. So tomorrow, what? Okay. Tomorrow I'll go through a whole nother lesson, and it's more simplifying with variables. And then you'll get all your papers. There's Friday. Oh my gosh, we have so much.
The highest will go up to?
No, there's a 5th root. I think on your worksheet, but you could, I can go write them down in a second if you want me to write some 4th and 5th.
But it's the same thing, right?
Yeah, like if I was going to do some 4th roots, I would just do, what's 1 to the 4th? 1. There's really no need to even write that one. What is 2 to the 4th? Is that 64? What is 2 to the 4th? Oh, that's 16. I knew that. Okay, what is 3 to the 4th? 81. What is 4 to the 4th? Okay, that's probably plenty to write down there. See, I don't have to write many of those down.
Oh, we have to do the 4th?
Okay, well, I don't know. She was just asking. It's not going to go up above a 5th root. Watch how many I need to write down for a 5th root. I don't even need that one, really. 2 to the 5th, I think, is 32. And then watch, 3 to the 5th is 243. I really don't need to go above that. So if you have a 5th root, it's probably going to be one of these 2 numbers that goes in it. Okay?
Now, for the 5th root, would we have the absolute value bars if it were?
No, an odd root, you never have absolute value bars.
Oh, so
It's an even root with an odd power answer.
I'm totally going to mess that up.
So that's why, I'm really, I'm not stressed over that, but it is a rule. We should know it. The book does it. I don't know that the worksheets really have that on there, but if
it's the 2nd and the 4th
if
power,
it's an,
your exponent is
yes, if it's an even root and your answer has an odd exponent.
Even root
Then you put it in absolute value bars.
odd.
Okay, that's kind of like,
Okay, so I had it backwards.
yeah. If it's an odd root, it doesn't have, it can be negative. Remember, an odd root can have a negative number underneath.
But
So,
an even root
an
can't have
even
a
root
negative.
can't have a negative. That's why if it ends up with an odd exponent, it's really, I don't know, it's weird. Okay, so that is that lesson for today. Do y'all feel like y'all need any other problems? No. Okay, this chapter's going good. Y'all handled that like champs.